Good afternoon, sir.
Good afternoon.
Yes, sir. Sir, actually, I want to ask some one thing.
Yeah, please tell.
Actually, sir, I want to ask, since you are actually PhD student in IIT Bombay, I want to ask, where you are taking coaching classes for chemistry?
Oh yeah, that question you asked last day, right? That the
Yes, sir. I asked, but just the
there
call
is
got
a yes,
disconnected.
there is a connection issue, and I explained in that last moment of that video. I was able to connect again, but during actually I completed during that time COVID, before COVID, so that time online coaching is not very popular. So I
Yes, sir.
suggest you, if you have offline coaching, which is not very far away from your home or where you are living, then you can definitely go. But if you are think that some offline coaching is not available in your area, you should definitely join the online coaching. So now right now there is many online coaching is there, but I will not take any particular name. I think you know what is the best and all. So and
Yes, sir.
that are not very expensive, that are very cheap, like within 6,000 7,000 I think, when I checked last time. So you will get all the three courses for inorganic, organic and physical.
Okay, sir.
So it is better to go with that online one, I think, because and for the online one right now also there is some support, I think, from WhatsApp. So if you have any doubt regarding their videos and all, they will help you in that
Okay, sir.
WhatsApp messages. So make sure you get the right coaching. So I suggest better to go to the online, because there, and instead of if you are you it is better to go in I want to say that better to go to online rather than traveling so much. If you go for online offline coaching, you have to travel.
Yes, sir.
That's why if you are preparing for the CSI net or GATE or any chemistry competitive exam, so you should definitely take online coaching.
Okay, sir. So now you're saying if you want to here also in our locality there is no offline coaching available, sir. So online
Actually,
coaching I am looking for it. I am basically attending online coaching from this several YouTube channels such as Weight Team Academy, and then one coaching named Textbook Super Coaching.
I
Is that
cannot
all right?
uh, uh, I cannot suggest a name because there is nothing to suggest. But during, if I can say it, what is it? I can say it, but during my time, I thoroughly read some previous year question paper along with some textbook when I prepared, because that time online coaching was not very popular.
It
Okay.
wasn't popular, you are saying.
Huh. So,
Okay, sir.
now the question pattern also changes. So, and that cutoff
Yes,
marks
sir.
is also getting higher day by day. So it is better to go for a coaching. Without coaching, it's maybe difficult. Or sometime I remember I missed GRA within just for 5 marks one time. So that is
Okay, sir.
why you have to do coaching. And main thing is just you have to practice questions. Whatever you read, that is
Yes, sir.
fine, whatever from the books or just solve all 10 years previous 10-year question. Now in YouTube, or as hard copy question is not available from last 4 5 years. So from the
Yes,
last
sir.
4 5 years you will get that memory based question solution in the YouTube. So you
Yes,
have to
sir.
do that for that. And main thing is that solving the question, because sometimes you know many deep knowledge on a subject, but if you don't solve the questions, other than uh, in the exam you may not remember all your knowledge, or may not
Okay, sir.
able
So
to
what I'm trying to say
utilize
is like you have to read the concept stop thoroughly and then like practice
huh.
solving PYQs.
The concept you have to read first, read the concept, and then
Yes.
with that topic, which topic you are reading, let's say organometallics, let's say thermodynamics, let's
Organometallics.
say quantum, whatever topics you are reading, just solve the previous year questions within that topic.
Okay,
After
sir.
solving previous year question, then you can have some, right now very mock tests are also available in online platform,
Yes, sir.
and then you will have an idea how much you are prepared. One,
Yes, sir.
I also think that if you are not getting, let's say 100 in the mock, and you are thinking that cutoff will be like 120, 125, but don't think in that way, I will not able to qualify. Don't think that way. Mock is only a mock, real exam is a real exam.
Yes, sir.
So my suggestion is, whatever the topic you are reading, or just finish 3 4 topic at a time, like
Yes, sir.
15 days, 20 days, or 1 month, or then after that topic you solve all the questions available, and most of the
Yes,
questions
sir.
available in YouTube.
Okay,
They have
sir.
every topic. So try to focus more on questions rather than
Yes, sir.
reading some foreign author books.
Right, sir. Right. Okay.
Then you will definitely able to qualify.
Okay, sir.
Any
Fine,
other?
sir. I'll do it, sir. I'll practice more and more PYQs, sir.
Huh. So PYQs are all available, and some previous, like old question paper for CSI net, like 2016, 17, 18, that are also available.
Yes,
So,
sir.
so like 10, 15 years questions are available in online. So you just go through it and you will have an idea. I think that concept all this year remains same, just they change the question.
Sir, I didn't get you.
The concept which you are reading, which you are
Yes, sir.
gaining your knowledge, that questions, that concept remains same all the time, all the last, let's
Yes,
say
sir.
20 years, but they
Yes, sir.
just change the question,
Yes, sir.
but the answer is remain same all the time.
Okay, sir.
So it is more, your chance to get qualify is the more you solve the question.
Yes, sir. Okay.
If you read a normal book, like which in Indian author book you can read just to get the knowledge of that topic, after getting
Yes,
that
sir.
knowledge, solve the question. That is the only criteria to qualify.
Yes, sir.
Not only in the CSI net, any exam.
Yes, sir.
Without solving the question, you will not able to test your knowledge.
Okay, sir. I got it.
Okay, so
Yes,
spend
sir.
more time on solving the question papers.
Yes, sir. Sure.
Say any doubt from the last and in within this course, like which we are talking about the week 4. So if you have any doubt, so we'll go through that, and
So,
after that,
I think last class I didn't attend, sir.
no, last, this is third, week third. So
Yes, sir.
week fourth video is already uploaded. So
Okay, sir. I haven't checked it.
so if you have any doubt, have you, then you can go through it. You can tell me. After that, we will just solve the regular question paper, and then I will discuss the some important topics which has
Yes,
been
sir.
covered in this week.
Yes, sir. So you can discuss those questions, sir,
Huh.
and then we'll ask you if any doubts is there or not.
Okay.
Yes, sir.
So in this week we have completed uh, that week 4. So fourth week has been completed, and week 5 video has been already uploaded. So in this week we have read more on CH activation reaction. CH activation reaction is organic chemistry, or is a important tool to active the CH bond and then do that functionalization of the CH bond to get the desired product.
Does it apply in coupling reaction as well? Like CH bond dissociates to form CC coupling.
CC coupling, yes, CC coupling.
Yes.
CC coupling we will read later after this CH activation. So now
Okay.
we are just activating any of this CH bond and adding a functional group to that bond. Functional group means that can be any other group than hydrogen to
Yes,
get a
sir.
different molecule. So
Like a
this is,
protecting group you are saying.
huh?
Like a protecting group you are saying.
No, no, not a protecting group.
Okay, any functional group,
Any
like say
functional group.
acid function or aldehyde
Let
or
let's say you have methane, CH4.
yes,
We
sir.
activate one of the hydrogen of methane, remain rest of the three same, and
Yes, sir.
replace one OH group. So that will be
Yes, sir.
methanol. That
Methanol.
you can convert methane to methanol. Another
Yes, sir.
is
Okay.
that you have same methane and instead of hydrogen it put a chloride, that is
Yes, sir.
methane
Methyl chloride.
chloride. So like
Yes, sir.
that you can, and this is the only simply alkane molecule. You can functionalize this in a aromatic system like aromatic ring also, and
Yes,
that
sir.
is also selectively. So
Yes, sir.
we will see how this selectivity occurs and what is the important of this uh, CH functionalization and how it happened. What is the main what are the main three criteria for this CH activation reaction? Just we have go through in this week, and why that CH bond is activated, how you can characterize that activated CH bond. With that we have come to a important point, that is agostic interaction, which I have started discussing in the last week. So let's start the session with some discussing some questions, and after that
Yes,
we
sir.
will discuss some important topic from that book which I am referring. Okay, so welcome to again in this week 4 problem solving interactive session for NPTEL course Transition Metal Organometallic Chemistry Principle to Application. So as we are coming to this CH activation reaction, so so for the CH bond to active is a challenging problem. Why? Because the CH bond in an organic molecule is ubiquitous, that is so many CH bond is there, so the selectivity to active the CH bond is very much challenging. Also the CH bond is very strong bond, so to active this bond is also another important, and after activating this bond just we have to add another molecule to functionalize there instead of that hydrogen. So to do this, we have read that about the agostic interaction last time. What is it? Let's say if a metal is bound to a carbon atom, and so this metal is interacting with this hydrogen, and this type of system can undergo the beta hydrogen elimination reaction via the agostic interaction. So how you
Okay, sir.
see that agostic interaction is present or not? So when
So is it similar to hydrogen bonding? Like what happens?
this is not hydrogen bonding is different.
No, I'm saying is it similar to effect called hydrogen bonding?
No. Why
No.
not?
Okay, sir.
Because hydrogen bonding happen between hydrogen and an electronegative element
Okay, sir. Okay.
when that another atom is highly electron rich.
Yes, sir. Okay.
Okay, let's say
But here
water.
both are electric positive.
Yes.
Okay, sir.
and hydrogen bonding system become stabilized. But here it is different because of the, and that's why it is called the agostic interaction. Agostic,
Yes, sir.
AU. So it is called the agostic interaction. So with this interaction, so these bond become weaken. And also
Broken.
another point is that hydrogen bonding only applicable when hydrogen is attached to an electronegative high electronegative element like oxygen, nitrogen, not
Yes,
sulfur.
sir.
So that cases, or fluorine, when that hydrogen is attached to element which is highly electronegative. So if you compare electronegativity or HF, if you compare the electronegativity between the carbon and hydrogen, the difference is very
Yes, sir.
less.
Yes, sir.
So this
Yes,
is
sir. Electronegativity is very less between carbon and hydrogen.
high
Like it is like kind
electronegativity.
of you can say like negligible.
Huh.
But in the case of hydrogen attached to oxygen, or hydrogen attached to fluorine, then there is a huge difference in electronegativity.
That's why it's from the hydrogen bonding, and it stabilizes
Yes,
the system, whereas
yes,
agostic
sir.
interaction destabilizes the system. And we have also already read the beta elimination reaction. So
Okay, sir.
here, how to know that whether the agostic interaction is present or not in the system? So when this metal is interacting with this hydrogen, so these bond which I that carved arrow, so this bond will be
Yes, sir.
weakened. So when we know
Yes,
that
sir.
as the bond is getting weakened, so their coupling constant value will be increased or decreased.
Bond vacancies, coupling constant value will increase.
That will increase.
No, sir, bond is decreasing, so yeah, that's why coupling constant will increase.
That means the length, when this bond become weak, the length will increases, so their
Yes, sir,
coupling
bond length
become decreases.
decreases.
Okay, so with that, so it will decrease from the agostic interaction. So if we have a CH coupling in 13 cm, we can see that answer will be 75 to 100, so which is less compared to that of the normal CH coupling.
Okay, sir. So what I want to say is like, sir, because CH bond becomes weak due to agostic interaction, what happens is the bond length increases and therefore the coupling constant also decreases.
Huh.
Okay, sir.
So normal range of CH coupling, what is the normal range when there is no agostic interaction? It is about 122, or better to say 120 to 250
1 to
hertz.
2.
So
Okay,
it
sir.
is far higher from the norm when the acoustic interaction is present. As the metal is interacting with this hydrogen, so CH bond, it is a normal CH bond without acoustic interaction.
Yes, sir.
Okay, so this is a normal coupling constant. So when acoustic interaction is present, the 13 cm, we will see that decreasing of the coupling constant. Okay. Next question is second same type of question. A typical CH proton or CH bond or carbon or bond length in an acoustic interaction is. So we have seen that because of the acoustic interaction, bond is increases.
Yes, sir. Bond length increases, sir.
Bond
Yeah.
length will be increases. So
Increases, yes, sir.
typically the value is generally less than 100 to 110
Yes, sir.
picometer. But here because of the acoustic interaction, the bond will be increased beyond that, and the right answer will be option number B. So we have two consequences of this. For the agostic interaction, bond length increases from 110 to 113 to 119 picometer, and because of that
Yes, sir.
coupling between the carbon and hydrogen decreases. And if you take the 13C NMR with coupling with hydrogen, so generally we record 13C NMR as decoupled.
Yes,
You
sir.
know it? You have
So which means in the case of 13 centimeter, what happens is the coupling constant, if in case of agostic interaction, the coupling constant will decrease. But in the
huh.
case of proton NMR, what happens is the coupling constant again will be increasing.
No. Proton NMR is different. We are talking about the coupling. In proton NMR, we are talking. We are when we are considering the proton NMR, we are considering the coupling of proton with proton only, not proton and carbon.
Yes, sir. Only proton. Yeah, proton decoupled carbon.
So but when we are taking the carbon NMR, let's
Yes,
say
sir.
we have a molecule CH2, CH3, CH3. This molecule. So if you record
Yes, sir.
the 13 cNMR, how many peak you will get?
13 centimeter. Two peaks I'll get.
Yes, two peaks will get, absolutely. So one
Yes,
peak
sir.
for these two and one
For
peak
methyl and another for methylene.
ethylene. But
Yes, sir.
because why you say two peak? Because that 13 cNMR is proton or hydrogen decoupled NMR. It is
Yeah,
not
proton
coupling with
decoupled.
the
Yes, sir.
hydrogen. But if you are coupled with
Yes,
the
sir.
hydrogen, what will happen? So these peaks will be splitted because of
Splitted.
the
Yes, sir.
coupling with the proton.
Yes, sir.
But we are not do that in your experiment. Why? But to find the agostic interaction, you have to do it.
Okay, sir.
Because if you take the proton NMR, a 13C NMR with proton coupled, what will happen? Each of these, you know that 13C NMR signal is already very less because it takes
Yes, sir.
lots of scanning to get a 13C.
Yes, sir.
But again, if you do that proton coupled, then what
Yes,
will
sir.
happen? That each spectra will be splitted,
Splitted.
and
Like it will be
because of
showing like splitting, like
uh,
multiplet or singlet or doublet, like
like
that.
proton NMR, and
Yes,
because of
sir.
the splitting, if this peak is like this, when it is a only peak, if it's splitted
Yes, sir.
into a doublet, so its peak will be just half of its intensity. Okay,
Okay, sir.
let's say it's
Like if it
splitted.
is coupled with carbon and NMR, then the intensity will of peak will decrease.
Because of that doublet,
Yes, sir.
intensity will be decreased, and then it take another longer time. Also it complicated your analysis. That's why we are not doing proton coupling 13C, but for finding the agostic interaction we have to do the 13C NMR coupled with the proton. Then only you can get that 1J CH value.
Yes, sir.
Got it? Okay.
Yes, sir. And 13C, what happens is because of agostic interaction, the coupling constant value like it decreases.
Decreases. Yes.
But in the case of proton NMR, what happens is this 13C NMR, this coupling constant increases.
Yes.
Right, okay, sir. But CH range is between 100 to 110 ppm, right?
This is the
ppm.
bond length. Bond
Yes,
length.
sir. Glucometer. Yes, sir.
Bond length. CH, normal CH bond length. Okay.
Yes, sir.
So then the another question. This question is important. We will discuss it.
Yes, sir.
So in platinum 2 catalyzed functionalization of methane to methanol and chloroform, the oxidant used is.
What is this?
in this reaction option you can say all are oxidating agent.
K1O4.
No. So
Hmm.
here we
Methyl
will use
triacetamine.
here all are oxidating agent.
Yes, sir.
Okay, so the particular reaction for platinum catalyzed functionalization of methane to methanol and methyl chloride oxidative used is
K,
K2PtCl6.
K2PTCl6. Okay, sir.
This why? For that we have to look for that catalytic cycle.
Yes, sir.
It is an example of, yes, here is that catalytic oxidation of methane to methanol and methyl chloride.
Yes, sir.
Okay,
Yes, sir. Visible, sir.
so what will happen is we have a first this compound which is a catalyst our, and here you can see that overall charge is positive, so
Yeah.
here platinum is in +2 oxidation state. So what will
Yes, sir.
happen, it will form a sigma alkane complexes with the methane CH and activate one of the hydrogen. So in the next step what will happen, this will eliminate H plus and it will form the sigma alkyl complex. So I use two terms, one is sigma alkane complex, another is sigma alkyl complex. So the first complex is, that is this one is sigma alkane complex. Why? Because this metal is interacting with an alkane intermolecularly,
Okay, sir.
intermolecular interaction, and here this CH bond is not broken, so this is
Yes,
a
sir.
sigma alkane complex. When this bond,
Agnostic interaction is taking place, sir.
when this bond is breaking, then it's form a sigma alkyl complex, because H
Okay.
plus gets released and methane methyl group CH3 minus is
Yes, sir.
with the
Yes, sir.
platinum. After that, if you used the, instead of methane, if you use deuterated methane like D plus, then what will happen, this D plus will taken by this CH3 alkyl group and it will be CH3D, and it will go on in the catalytic cycle.
Yes.
But in the, with the formation, after formation of this complex, if you use the another oxidating agent like PtCl6 2 minus, here platinum is in +4 oxidation state.
Yes. It's for oxidation state. Yes, sir.
So this will react in presence of this compound and it will form PtCH3Cl5 2 minus. Here also platinum is +4 oxidation state in this complex.
Yes, sir.
After formation of this complex, if release PtCl4 2 minus with 1 chloride, it will give the CH3Cl, that is the methyl chloride, and
Yes,
another
sir.
it will react with H2O to generate the HCl, and PtCl4 it will give the CH3OH, that is
CH3OH.
methanol. So here platinum 4 CH3 intermediate and observed in 1H NMR. So
No.
here
Yes.
that reaction undergo to platinum 4 CH3 intermediate. So what will happen? CH3 undergo negatively charged. Here also it is negatively charged, and
Yes,
here
sir.
also it's undergo this negatively charged. That is the methyl moiety, which is an alkyl
Okay, sir.
moiety. And because of
Yes,
that
sir.
negatively charged, if you do or run the experiment in a NMR, you will see that highly shielded or deshielded. Methyl
I'm
is
sorry, sir.
highly when the methyl it says that platinum 4 methyl intermediate and aqua chloro tetrachloro platinum methyl intermediate and Cl5 PtCH3 intermediate observed in NMR. So
Yes, sir.
what is the characteristic of this CH3 methyl in the NMR? It is in
So
proton
CH3
NMR.
is negatively charged, sir.
So what will happen in proton NMR?
It will be going towards deshielded region.
When it is negatively charged, that means
Oh, sir, it will be like shielded region, sir.
it will be highly shielded region. So value
Yes,
for
sir.
this CH3 will be like hydride. When hydride comes, which hydride come where? In proton NMR spectra or which?
-1, -2.
Yes, hydride comes generally minus 3, 4, 5 region.
Okay, sir. Oh.
Okay, so
Yes,
methyl
sir.
also will be in the negative ppm value region. So
Yes, sir.
if you observe the methyl peak in the proton NMR in negative region, you will know that this reaction is undergoing via platinum 4 intermediate with
Yes, sir.
platinum alkane complex.
Platinum alkane complex. Yes, sir.
Okay, let's go to our slide. Okay, so here option will be option number
K2PtCl6.
D.
Yes, sir.
Okay, so another thing in this slide, in this cycle, there is a two cycle where this first cycle and in this is the second cycle. So first cycle you can see that the product or catalyst or the active species is forming in a catalytic fashion,
Yes, sir.
but that is it is rolling. But in the second scheme or second thing, when we are using PtCl6 as an oxidant, this cycle is stopped with this chloride and methanol formation with the elimination of KPtCl4. So that means here the reaction is stoichiometric, whereas in here the reaction is catalytic.
Catalytic. Okay, sir.
Okay, this is an important part of this for this reaction. Okay, the next question is predict the product of the reaction. We have octane
Yes, sir.
and it is react to it a boron reagent. So what will happen?
So the boron-boron bond will like dissociate and then it will couple with carbon to form boron-carbon DC bond. Will that be the case, sir?
Yes. So this
Okay,
is
sir.
an example of selective CH activation as well as the functionalization.
Yes, sir.
Why CH bond is difficult to active? As we are saying that Then in this molecule you have this terminal CH bond as well as the CH bond in between.
Yes, sir. In between.
So here it is very difficult that which CH bond will be active. So in
Yes, sir.
2000 Hartwig used this catalyst, which is rhodium catalyst,
Yes, sir.
in 150 degree centigrade. He used this boron reagent and make selectively. Okay, so this reaction is, as this rhodium acts as a catalyst, so this reaction is catalytic. So catalytically as well as selectively activated the one of the terminal CH bond and functionalizes with the boron reagent.
Yes, sir.
But interesting thing to note here that not both the terminal CH functionalize. So here
Yes, sir.
the only one CH bond is functionalized. So the
Yes,
option
sir.
C will not be the correct answer. Option A will be the
The
correct answer. So
correct answer.
both side functionalization will not happen.
Yes, sir.
Only it will be functionalized in one of the side to give this boron compound. Boron compound are very difficult to prepare, and also
Yes, sir.
the selectivity of this CH bond is
Like it's a
also.
short-lived species. You're saying
Huh?
it's a boron compounds are short-lived species. You're
Huh.
saying.
And
Okay,
also
sir.
this compound act as a starting material in very coupling reaction like Suzuki coupling reaction. CC bond formation is required. That's why selectively, that means catalytically as well as selectively functionalize using this boron reagent.
Yes, sir.
Next question is,
Because here this also happens because of acoustic interaction, right?
yes.
Okay, sir. Like only if in the case of acoustic interaction, only one terminal hydrogen CH will be involved in the acoustic interaction, not both.
Huh. Agostic
Okay, sir.
interaction is different. Agostic interaction, this is not kind of agostic interaction. Agostic interaction, this is a form because of the formation of sigma alk. So when a CH bond is activated, not only the agostic interaction is responsible for the formation of the CH bond. So in that lecture also we have seen there is a different types of interaction with the metal and the hydrogen.
Yes, sir.
So agostic interaction only considered when when this molecule is, or the molecule where the CH is activated is bound with the metal center.
Yes, sir. Like
Agostic
here there is presence of two terminal CH bonds, so which means either one will get bounded with the rhodium metal,
uh,
and that will undergo acoustic
other
interaction.
one will be gets free and that will undergo the activation and functionalization.
Okay, sir.
Okay. So option A will be right answer.
Right. Yes,
And here also the another question, predict the product
sir.
of the reaction.
Yes, yes, yes.
So what will be the answer for this?
Wait, sir. Wait. So will it be option D?
Okay. So first of all, we have to calculate the total number of valence electron for the given compound.
Yes, sir.
So, so molybdenum is chromium, molybdenum, tungsten. So it is 35 4s1. So that means it contains 6 electron. 6 electron for the
Yes,
molybdenum. CO contains 2 electron. That means 6 plus 2 8. And here we have 2 of these phosphine ligand. So one
yes, sir.
phosphine ligand will donate 2 plus 2, that is 4 electron for the
All electrons.
2
Yes, sir.
phosphorus. So 4 electron per one ligand, so 2 electron will be her. So, so 4
8 electrons, sir.
1 2 3 4 4 electron per one ligand. So 2
Yes, sir.
ligand,
4 into 2 equal to 8.
8.
Yes,
So
sir.
molybdenum 6 plus CO2 8. So
2,
8 plus 8 will be
16.
16. So given complex is a 16 electron complex.
Yes, sir.
So 16 electron complex, we know that this is electronically unsaturated,
Yes,
and
sir.
also molybdenum is a 4D element. So this is size is also big. So coordination
Yes, sir.
number can also be increased beyond 6.
Yes, sir.
So if you say this option D, what will happen is difference is there is no CO moiety.
Yes,
As there
sir.
is no CO ligand, that means it becomes or it remains as a 16 electron species.
Yes, sir.
Okay, but in option C, as the compound is coordinatively unsaturated and electronically, so it can should it wants to saturate its electron. So it will take 2 electron with that SiH bond through the SiH activation, and it will undergo the oxidative addition reaction to form the product. So here product you can check option number C will be the right answer.
Yes, sir. Like why? Because like it can say like since molybdenum is there, so which means like it can it start increasing its coordination number.
Yes, because for the higher element we have seen that coordination number is increases, or it is not
Yes, sir.
stopped at 6 because their size is large.
Yes, sir.
So here it is 7 coordination number is there.
Yes, sir.
Okay.
Yes, sir.
So here option C will be the right answer, and it is also a question where that is like CH activation, which we discussed for that methane CH4. Similarly, for its higher analogue like silicon hydride, it will undergo the hydride and to give the sigma alkene complexes. Okay. So option C will be the right answer. Going to the next question. Next question is very simple question. It says that the reaction that does not occur for D0 metal complexes.
This will occur for D0 complexes. So is it oxidative addition?
Can we explain how it is become oxidative addition, not reductive elimination?
Okay, so let me just think once again. Sir, actually, I'm not sure about this thing.
Okay, so we are considering about the D0 metal complexes.
Yes, sir.
So D0 means there is no electron in d
No
orbital.
electron involved. Yes, sir.
No electron, no d electron is involved.
Yes, sir.
So let's consider that oxidative addition. So in
That is metal
oxidate,
will be in higher oxidation state.
so metal will be in higher oxidation state. That
Yes, sir.
means you have to take. So what generally happen? Metal does undergo plus 1 oxidation state to plus 3 oxidation state.
Yes, sir.
That means you have to take electron from the metal.
Yes, sir.
Okay. So if metal in D0 state, that means metal doesn't have any d electron. So how
Yes,
you
sir.
will take a d electron from that metal?
Yes, sir.
Okay. So oxidative addition, so during oxidative addition, metal is getting oxidized. That means metal is giving
Like the,
electron to someone.
yes, sir. That is oxidation state increases.
Oxidation
With the
state,
metal.
that means metal is giving if it doesn't have any electron, how it will give?
Yes, sir.
So it will doesn't undergo the oxidative addition. But for the
Yes, sir.
reductive elimination, what will happen? Metal will take electron from other.
Yes, sir.
As it is d0, so entire d orbital is empty. It can take
Empty.
electron from easily from other. So
Yes, sir.
reductive elimination will be very faster.
Yes, sir.
So for the migratory insertion and beta hydrogen transfer, it does not depend on the electron cloud.
Yes, sir.
Okay, so that will never occur. D0 system is the oxidative addition.
Yes, sir.
Okay, it is clear. The next question.
So one more thing, like in the case of oxidative addition, when the ligand comes and attack, when the Lewis space attacks the Lewis acid, what happens is the electrons have been given to the metal atom. But in the case of reductive elimination, what happens is the electrons have been metal takes electrons from the ligands.
Hmm.
Yes, sir. Okay, in the case of oxidative addition, ligands give electrons to metals, but in the case
No,
of
no. In oxidative addition, metal is giving electron to the ligand.
yes,
Oxidating.
sir.
So that means oxidation is happening. Oxidation happening means loss of electron. So metal is losing its electrons.
Yes, sir. Ah, yes, sir. Oxidation, yeah, loss of electron. Yes, sir.
Okay, and oxidation reduction in terms of the metal only.
Yes, sir.
Okay.
Reductive elimination means it will take electrons from that is gain of electron. That is, it takes electrons from the ligands.
It will take
Okay, sir.
electron from the ligand, and metal
Yes,
will
sir.
be in lower oxidation state
Yes, sir. Like from higher oxidation state, it will become lower oxidation
for
state.
reductive elimination.
Yes, sir.
Okay. Next is, so here our option A will be the right answer. Next question is the correct statement about the following metal hydrogen metal hydride carbon interaction below. So here the correct interaction you have to just
Correct statement number following MHC bond group MH binding with eta 1H
so
eta 2H.
binding mode is eta 1H, binding mode is eta 2H, HCH bond angle at carbon is linear, and the distinct 3
3 CH
CH bond interact directly with the metal center.
trace environment. Do you trace whenever CH name? So I would say binding mode is eta 1H
Yes.
because metal is coordinating with the only one
Yes,
hydrogen.
only one hydrogen is coordinated with the metal. So binding mode is eta 1H.
Eta 1H. This agnostic interaction. Sir.
Not all interaction is acoustic interaction. It is eta 1 H interaction.
Yes, sir.
You are confusing acoustic interaction with other. Acoustic interaction I explained in last class. Let me show you.
Yes, sir. It is like when metal is attached to an alkane, and the terminal the hydrogen will interact with the metal atom.
Hmm.
Okay, sir.
Acoustic interaction is different.
Okay, okay.
Yeah, here you see.
Yes, sir.
So here which one is acoustic?
Option D. Answer no. Yes, sir. Option B is the right answer.
Yes.
B for ball.
Option B is the right answer. Here option A, you can see metal is interacting is only H, and this is a, and another thing is acoustic interaction is intramolecular interaction.
Intramolecular interaction. Yes, sir. Which
Intramolecular,
means
not
provided that metal should
intermolecular.
have a alkyl chain connected with it.
So this is an intramolecular interaction,
Okay, sir.
and for
That
the
is right.
T, it will be interaction between that carbon and hydrogen as a eta 2 fashion.
Yes, sir.
Okay, so acoustic interaction, don't say everything is acoustic.
Yes, sir. Provided that if the metal is connected with the alkyl chain, the
Yes,
terminal
alkyl
hydrogen
chain,
can interact with
and
the
there
metal
is,
atom.
yes.
Yes, sir. So okay, sir. This is not acoustic interaction.
Hmm. This is only binding mode is eta 1
Okay, sir.
binding mode.
Eta 1 H binding mode.
Hmm.
Okay, sir.
The next question
Got it,
is,
sir. Rate of auto reaction RUP engineering becomes what? Sir, one more thing. Before approaching this question, can we just take out the total electron count that is involved here?
in this question,
Yes, sir. Then we can determine like what exactly is the oxidation rate of ruthenium and all.
hmm, count the electron.
No, ruthenium. So ruthenium will be in zero oxidation state.
Hmm.
Yes, because the all they are
All
all neutral
is
ligands.
neutral.
Yes, sir. TMA3 CH2 CH2. Okay, then TMA3. Okay. Then to the naphthalene, then to form. Also, sir, one more thing, we have seen this earlier also, that is, if in the case of D0, what happens is like metal actually requires electron, right? So which means relative elimination is more favored.
For D0 state, yes. What say? Tell me again.
Like sir, for D0 metal complexes, like which doesn't favor formation is actually the reductive elimination, right? Because metal needs electron.
For D0 system, the question you understand, it says that the
Does
reaction
not
does
occur.
not occur. For D0 system, which reaction will not occur?
Okay, sir. Okay, okay. Which reaction doesn't occur? Okay, sir.
It is not asking which reaction will occur for D0 system.
Okay, does not. Okay, sir. Okay, it's highlighted in bold. Okay, sir.
Okay, so
Yes, sir.
D0 system, metal complexes will does not happen oxidative addition, because again I am explaining oxidative addition, metal is getting oxidized. That means if someone is taking
Loss of
electron from the
electron.
metal, so if metal is in D0, that means there is no electron, zero electron, how it will give to someone electron?
Yes, sir.
But when it is, that means oxidation is not possible for D0 system, but it can be undergo the reductive elimination state, because it can have electron from that another molecule to fill in the d orbital.
Yes, sir.
Is it clear?
Yes, sir. End of clear.
Okay. Acha. So here this question, here is another example for CH activation reaction.
Yes,
See
sir.
here also you can count ruthenium is which group?
Iron group,
Iron ruthenium
FeRuOS.
oxynium. So that is uh, iron is in
4D.
D8
Yes, sir. D8. D8S2. Yeah, 10 electron.
D8 system. So D8, so it will have 8 and another 1, 2, 3, 4. 4 phosphine ligand. So
Yes,
4
sir.
phosphine ligand will be 4 phosphine ligand will be 4 into 2 8, so 8 plus 8 16. So this is
Yes,
also
sir.
60 electron system, coordinatically unsaturated. It can undergo the oxidative addition reaction.
Yes, sir.
So it will undergo the oxidative addition reaction with this naphthalene ring, and naphthalene ring, that there is two different position. One is this position, one is this position, another is this, two different position. So which
Yes.
position it will undergo the undergo the CH activation. So it will undergo a CH activation reaction in a particularly this position, because this
Yes,
is
sir.
less hindered position
Less
compared to
sterically hindered position.
compared to that other one.
Okay, sir.
Okay, so it will undergo the oxidative addition reaction via CH active oxidative addition via CH activation. It will form, which one will be the right answer?
Is it option A?
Yes, it will undergo that bind with this ruthenium and with that ruthenium hydride. And option
Sir.
C you can have the, which
That is
is
sterically hindered, sir.
binding with the another position which is sterically more hindered. So
More
it
hindered,
will
yes, sir.
only bind with this mode. So option A will be the correct answer for
Yes,
this
sir.
question.
Sir, one more thing is like since the oxidation state of ruthenium changes from 0 to plus 2.
Hmm.
Okay, sir.
Okay.
Yes, sir.
The cleavage of CH bond during CH activation by a transition metal involved.
So you
It
just
is
use one relaxation
just a
transmission.
theoretical question. It is just a theory behind the question which we have discussed last.
Yes, sir. Cleavage of CH bond during CH activation by transition flow. Agostic interaction. B.
And
Okay.
for the naphthalene case we have just discussed.
Ah, yes, sir. Okay, like you are saying oxidative addition.
Yes. So this bond will be cleaved via oxidative addition, and also that this bond is also cleaved via agostive interaction. Reductive
Okay,
elimination
sir.
will not cleave the CH bond. Also the metal to ligand sigma donation.
Okay,
Which is the
sir.
metal to ligand?
CH bond of this naphthalene you are saying. Okay, sir.
Yes.
That leads to
And
oxidative
another
addition.
C, another option is metal to ligand sigma donation. Is it possible to donate sigma electron from metal to ligand?
No, sir. Pi electrons is possible.
Yes.
Ligand to metal is sigma
Yes.
bond, whereas
And
metal to
metal to
ligand is
ligand
pi
is
bond.
always pi. So this option is also statementally wrong.
Yes, sir.
Okay. So option A and B will be the right answer for this question.
But sir, here it is not mentioned that it is MSQ or something.
No. In the exam, it will be not mentioned whether the section is MSQ or MCQ. I think one section will be there where there will be both MSQ and
Okay, sir.
MCQ combined.
Fine, sir.
But MSQ question can also have a single answer.
Okay, sir. Okay.
Okay, MSQ question will also have a single answer.
Yes, sir.
So you have to take care of that.
But exam will be computer based, sir. So which means the option will be like if it is box means the or there will be two options present. Am I right?
Huh?
Like during the case of exam, we have to ourselves figure out whether it is MSQ or MCQ.
Huh. It will be not state whether it is MSQ or MCQ.
Okay, sir.
There will be option to tick all four.
Okay, sir.
Okay, so for MSQ you have to tick up if the multiple option is correct, you have to tick the multiple thing. If it is not, then you have to tick the only the one option which is correct. And
Yes, sir.
I think I am not sure. I think for MSQ question there is a, like say if you not answer all the correct one, you will get partial marking. I think I am not sure.
Okay, sir.
Okay. Okay, let's go to the next question. I think this is the last question. So in the reductive elimination step, an electron rich late transition metal would. This is also an important question.
Reductive elimination step, electron rich late transition metal would not hesitate in nucleophilic attack favored the elimination reaction hinder the elimination reaction in the metal
Don't
attack.
need to hurry. Just take your time and
Yes, I'm just reading the options, sir. That's
uh,
all. Active elimination step, electron rich late transition favor the yeah. Sir, can it be option A?
okay. So, so let me explain. So
Yes, sir.
last question. This question. This
Yes, sir.
question says that the reaction does not occur for D0 metal complexes. So what does it D0 means? D0
Metal
means
is higher
that
oxidation state.
metal is in higher oxidation state.
Yes, sir.
Okay, that means it can be plus 4, 5, 6, like that. That means metal electron is very rich. Not, it is very
Okay.
poor. Metal is electron deficient.
Yes, sir.
Okay, so when the metal is electron deficient, it will not undergo oxidative addition, rather it will undergo
Reductive
reductive
elimination.
elimination.
Oh.
But in this question what is say, in reductive elimination step an electron rich late transition metal.
Electron rich transition.
So
Yes, sir.
for reductive elimination step we have seen in the last question that metal should be electron deficient,
Yes, sir.
but here our metal is electron rich.
Yes, sir.
So what will happen in reductive elimination step? It will be
Okay.
favored or not?
So it will hinder the elimination reaction.
Yes.
Okay, sir.
So that means the reductive elimination step metal is getting reduced. That means metal is gaining electron.
Yes,
When
sir.
metal is already electronically rich, is it possible to gain more electron when you are electronically rich?
No,
Obviously
sir.
no.
You
So
have to lose electrons.
yes, so for electron rich system it will undergo faster oxidative addition reaction, but
Yes, sir.
reductive elimination reaction will be slower. So option
Slow.
C will be the correct answer for this question.
Okay,
So
sir.
for electron rich late transition metal, reductive elimination step will be highly hindered.
That is in the case of reductive elimination step. That is, there won't be much electrons to the metal atom.
Sorry?
That is in the case of reductive elimination step. What happens is the metal will tend to lose electrons.
Again you are doing
Hmm.
mistake.
That's the
Reductive elimination means reduction means gain of electron.
first
Oxidation means
reduction.
loss
Okay,
of electron.
let's write it, sir. 1 second.
And oxidation and reduction happen on the metal center.
Yes, sir. Okay, got it, sir.
Oxidation. Let me write also.
Sorry,
Oxidation.
sir. If you forgot.
Oxidation. Loss of
Loss of electron.
electrons. And reduction,
Gain of electrons.
gain of electrons. Okay. And oxidation reduction considered on metal center. Okay.
Yes, sir.
So when metal is electron rich, when metal is electron rich, so what
Yes,
will
sir.
happen? And two, when metal is electron deficient. So two cases. Option A, when metal is electron rich. Another case, when metal is electron deficient. So first
Efficient.
case, what will happen? Oxidative
Oxidative addition.
oxidative addition favor.
Yes, sir.
Reductive elimination
Is not favored.
hindered or not favored.
Yes, sir.
And for the second case, when metal is electron deficient, reductive elimination will will favor or disfavor?
Will be favored.
Favor.
Okay, sir.
And oxidative addition will be disfavored.
Disfavored.
Is this clear?
Yes, sir. Now it's clear. Okay, sir. I'll make it a note of it. I'll make a note of it, sir.
So with that, I think we completed all the 10 questions which has been
Yes, sir. Clear.
uh,
Sorry, sir. If you can.
no, that's why I am here.
Yes, sir. That's why I'm less confused with this. That's why.
uh,
Now it's clear, sir. You made it crystal clear.
hmm. let's go back to that book.
Yes, sir.
So here in this slide you can have some example. Okay, so in this example here you can see that here you can see that all the molecules are in 18 electron species. So for CH activation reaction or any kind of oxidative addition reaction, we are also told last day that metal center should be coordinatically as well as electronically unsaturated. That means for lower 3D or metal center, it should be coordination number should be below 6 and the total electron count should be less than 18 to undergo the oxidative addition reaction. So in presence, so here the catalyst when is electronically saturated, let's say having the 80 electron, so that cases it have to lose some of these. It can say that this molecule in presence of H new light, it loses the H and become, so this is required to undergo this thing. Some transformation, so that should be electronically rich to undergo that reaction. We have all discussed this. Next we will go to that another topic. Let's see. Here you can see that different kind of binding mode. So here we have question today. This is an eta 1H binding. So this is eta 2H binding when metal is bind to the 2 of this hydrogen of methane. When metal is binding to the 3 of this hydrogen to the methane, it is called the eta 3 mode of binding.
Yes, sir. Okay. Eta 3H. Okay, sir.
And when metal is bind to one of the hydrogen and one of the carbon atom, so it is eta 2 carbon hydrogen mode of binding. And for the agostive interaction, metal should be bind with that carbon and another hydrogen will be interacted. So you can see one theme, all 4 1 2 3 4, these are intermolecular interaction, whereas for agostic interaction it is an intramolecular interaction.
Yes, sir. This inter means with between two molecules. Intra means within the molecule.
Yes,
Fine, sir.
intramil within the molecule. So here metal is bound to this carbon by some chain length, like beta hydrogen elimination as we read. So this is called the agostic interaction. And another thing, that where the agostic interaction is present or not, we can confirm it via various techniques. Like X-ray is not very prominent for hydride or hydrogen because of the very smaller size, and but the neutron diffraction can do so, and we can see that bond length, sorry, carbon 13 NMR also give you that particular coupling constant value between the carbon and hydrogen in 13 NMR. If it is less, corresponding to the normal value, it will give you, you can say, sort of agostic interaction is there. Another thing, that here in this question is suggests that UV experiment, UV visible characterization. So here the chromium hexacarbonyl is react with CH4, it will give pentacarbonyl chromium methane. So heat lambda max shifted from the 229 or 280 nanometer to 489 nanometer in methane under low temperature. So when it is represent in C6H12 cyclohexane solution, so at room temperature of 300 Kelvin, it will, in laser flash condition, lambda max increases, which also says that formation of sigma alkane complexes, transition metal sigma alkane complexes. So here also for the rhenium complexes, there is a impedance of C5H10 cyclopentane. It undergoes the eta 2 CH interaction to give this kind of bonding. So, but here you can see that two protons are appear in that different same in the NMR time scale. And this question we have already discussed. So here in the first complex, when the molybdenum is interacting with the one of the SiH bond, and it from sigma alkane complexes, and after that it undergoes the oxidative addition and it behaves as a sigma alkyl complexes. So this is the difference between the two, sigma alkane and sigma alkyl. When the metal is interacting with that carbon or silicon hydride bond, then it is calling that sigma alkane complexes, and when the CH bond or Si bond getting clipped, and it from metal hydride complexes, then it is calling as a sigma alkyl complexes. So I think it is clear
Yes, sir.
between the what is sigma alkane complexes and what
Yes,
is
sir.
sigma alkyl complexes. So it is little bit uh, tricky. Then
Could you repeat once again sigma alkane, sigma alkyl? Like in this case, what happened is like SiH4, right? So SiH3 and H is there, so which is metal coordinates with SiH3 and H bond. Then
yeah,
what happens is the bond dissociates such that hydrogen attacks on the molybdenum.
yes.
Because the molybdenum is in the 4D series, so which means it can increase its own coordination number and then oxidation state as well.
Hmm. So
Okay,
here the left side complexes, that is this one, this one,
yes, sir.
this one is called sigma alkane complexes. Okay, like you can write here also. So if you have metal and let's say CH3H, H. So this is sigma alkane complex. But if you write metal CH3 H, let's say H C H3, here it is not writing properly, I think you can understand it. So then this is transition metal alkane, ALKNE, alkane, and it is alkyl. Okay.
Okay, sir.
Here a very good graph is there. So how to explain this graph? So here you see it is a CH4 methane is interacting with one of the carbon hydrogen bond with a metal. So if so this is a intermediate or form the sigma alkane complex. So metal in presence of methane undergo the oxidative addition to form a sigma alkyl complex via intermediate of sigma alkane complex, which is okay. Then it also undergo the reductive elimination step to the methane via the same intermediate. So this graph is very explained very quite nicely. So in between, in the middle, we have sigma alkane complex, and in the left side we have sigma alkyl complex. With that, I think I have discussed most of the thing for this week, and the next week we will start discussing that another topic, that is C bond activation reaction.
Okay, sir. Here we'll be like getting the coupling reactions and all, right? We'll be studying.
Yes.
Fine, sir.
Okay. Any question from this?
As of now, nothing, sir. But I'll just go to that PDF, sir. It is actually kept in the portal, right?
Yes, it is available. First day I show you how to get this.
Ah, yes, sir. Okay, sir. Okay.
Where there is a video link, when you are getting the link for the videos, just go down. You are reading it from the YouTube, or
No, sir. I'm reading from the portal itself, sir.
yeah, if you go to that portal, that week 1,
Yes,
week
sir.
2, and there is an assignment. So in that series, just left, you go down. There will be a series that books.
Okay, in the books option, it will be
In the
available
books
in
option,
the PDF format.
you will get everything in PDF. This you will get this PDF.
Okay, sir. Fine, fine.
Okay,
Yes, sir. Fine.
and I think I have also uploaded in that drive. You are getting a sheet, na recording sheet through an email, and that
Yes, I get the updates about email in the
for
thing
the
like
week
week five
YouTube
lectures
link,
uploaded and
for
something.
YouTube
All this.
link for this session.
Yes, sir.
So I think there also I have uploaded. I'm not sure. If not, then I will upload it there. And also you just go to that, portal, and you will get that book. Okay.
Okay, sir.
Okay, then see you in the next next Sunday.
Yes, sir. Okay, sir. So one more thing regarding that preparation, you're saying better I should prefer online coaching than offline coaching.
Yeah, you can actually offline coaching, if it is available near you, you can go. There is no issue.
Yes, sir.
But if the offline coaching is not available in the
Yes, sir.
place where you live, then you can go to the online coaching.
Okay, sir.
And wherever you do the coaching, that is more important thing is you solve most of the questions,
Yeah, more PYQs have to solve.
more PYQ questions, and at least try to give before like 15 days or 20 days of your exam, try to give mock test, or at least one mock test in every month.
Yes, sir. Definitely.
And mock test questions are not previous year question, that is an entirely different question.
Yes, sir.
So there is some online platform where you can only buy the mock test also.
Yes, sir.
Okay, so like J Chemistry, Chem Academy, from that you can just go to that their test series you can buy
Yes, sir.
and give the test. That
Fine,
will
sir.
be important and for your preparation.
Yes, sir. Fine.
Okay, and this topic which we are discussing here is not very oriented or not cover all the topic of organometallic chemistry for CSI and NET. So these topic are some particular topic which we are discussing within organometallics. Okay,
Yes, sir.
so for competitive exam you need uh, more than these more than this course.
Yes, sir.
Okay, uh, I
Okay,
think
sir.
if you solve more and more questions, you will already get an idea what type of questions are
Yeah.
being asked, and you can read or plan your reading accordingly. That is the only way.
Okay, sir.
Okay, then see you in the next.
Okay, sir. Thank you, sir. Thank you very much. Have a good day ahead.
Hmm. Thank you.
Thanks, sir.
Okay, so with this, I have completed 10 questions plus discussing the some of the important topic which has been discussed in this week, and I hope this will be helpful for solving that portal assignment. Some portal assignments is generally the question based assignment, so but without the theory or without the knowledge of the theory you cannot approach a question. And also when you are reading or when you are solving a question, try to understand the logic behind that question. Sometime in organometallic compound, that 18 electron rule become very prominent to answer the questions. Like we have discussed that ruthenium questions where it has 16 electron loop complex, and after oxidative addition it becomes the 18 electron complex, and that is the most stable for this. So I think this will be helpful for solving that portal assignment as well as solving the problem in that exam. It will be better if we solve more and more questions and rather than reading lots of theory from different book, just read the theory from one book and try to solve question on that topic. That will be the only thing to get that a good knowledge of a particular topic. So with that, I thank you for watching this. I whoever will watching this is thing from that YouTube or recording list link, try ask them to join. I will ask them to join in that online problem solving session every Sunday from 4 to 6 p.m. and let your doubt cleared. As generally I stop this around 5:40 as nobody is there. And if you have any doubt, you can discuss with me, or okay, we'll see you in that next Sunday, that will be on 24th of August. 24. Okay. Okay. We have already started the CH activation reaction, and the next, that is the more another challenging bond to active, that CC bond, and functionalize the CC bond. We will also discuss that in next lectures. Till then, see you.